Welcome everyone. In this tutorial, we're going to dive deep into Euler P function, also known as Euler's totient function. Whether you're a beginner in number theory or just looking to sharpen your mathematical skills, in this video, we'll walk you through what Euler's P function is, how to calculate it, and where it is appears in mathematics. So grab your pens and notebooks and let's get started. Euler's P function, denoted as P of n, is a fundamental concept in number theory. It gives us the count of integers from 1 to n that are coprime with n. But what does that mean? Let's break it down. Two numbers are considered coprime if their greatest common divisor or GCD is 1. So if you want to know how many numbers between 1 and n share no common factors with n except 1, you use Euler's P function. For example, P of 6 gives us how many numbers from 1 to 6 are coprime with 6. In this case, the numbers 1 and 5 are coprime with 6, hence P of 6 is equal to 2. Now let's talk about how to calculate Euler's P function for any positive integers n. The formula for P of n is given by this. Pi of n is equal to n times 1 minus 1 over p sub 1 times 1 minus 1 over p sub 2 times 1 minus 1 over p sub k, where p sub 1 and p sub 2 p sub k are the distinct primes dividing n. So how does this formula work? It's quite simple. You start with n, and for each distinct prime factors of n, you multiply n by 1 minus 1 over p sub 1, where p is the prime factors. Let's work through a quick example. Let's compute p of 12. First, we find the prime factors of 12. The prime factorization of 12 is 2 squared times 3. So the distinct primes are 2 and 3. Now apply the formula. P of 12 is equal to 12 times 1 minus 1 over 2 times 1 minus 1 over 3 is equal to 12 times 1 half times 2/3 is equal to 4. This means there are 4 integers from 1 to 12 that are coprime with 12. Now let's talk about some special cases that makes Euler's P function easier to calculate. First, if n is a prime number, say p, then p of p is simply p minus 1. For instance, p of 7 is equal to 7 minus 1 is equal to 6. Since 7 is a prime number and all numbers less than 7 are coprime with 7. Here's the general idea of algorithm. First, start with p of n is equal to n. Second, for each prime factors p of n, update p of n as follow. P of n is equal to p of n times 1 minus 1 over p sub 1. Third, repeat until all prime factors are processed. Now, you might be wondering why Euler's P function is so important. Well, it appears in many areas of mathematics and computer science. One key application of Euler's P function is a number theory, especially in the proof of Euler's theorem. Euler's theorem tells us that if A and n are coprime, then this theorem is extremely useful in areas like cryptography, especially in RSA encryption. In RSA, we rely on Euler's P function to compute public and private keys. To wrap up, let's visualize Euler's P function for a range of numbers. Here we'll show a grid of numbers from 1 to 20. For each number, we'll highlight how many integers less than it are coprime with that number. As you can see, for n is equal to 1, there's only one numbers that coprime with 1 itself. For n is equal to 12, there are 4 numbers coprime with 12. The values of p of n give us a sense of how spread out the coprime numbers are. We've covered a lot of ground today, from understanding Euler's P function and its formula to applying it in real-world problems like cryptography. Euler's P function is an essential tool in number theory, with far-reaching application in mathematics, computer science, and beyond. If you enjoyed this video, don't forget to like and give comment for more in-depth tutorial. Thank you for watching, and I'll see you in the next one.